Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
All right, let's take a look at our lesson 6.2.2. In this lesson, we are going to continue solving equations, but we're going to notice that some of them involve distributive property, which is going to be like the very first thing that you're going to do in the entire process, having to do that before we even combine like terms and remove zeros. And then after we have a solution, we're going to focus on what we do to check that solution. Remember the 5D process, how the fourth D was to decide whether or not your answer is correct or not before you officially declare it. Well, that's what the checking of the solutions is all about. So sometimes a lot can depend on the solution of a problem. For example, when businesses calculate the cost of packaging and shipping a product, they need to come up with an accurate value. If they miscalculate by only 1 cent per package, ship 1 million packages per year, this small miscalculation could be costly. Solving a problem is one challenge. However, once it's solved, it's important to have ways to know whether the solution you found is correct. In this lesson, you will be solving equations and finding ways to determine whether your solution makes the equation true. All right, so Chen's sister made this riddle for him. I am thinking of a number. If you add 2 to the number, then triple it, you get 9. So your task is to build the equation on an equation match. You can use one of the student tools, I'm sure, for the online book to do this. Or you could just draw pictures of it. That would work too. And then what are 2 ways that Chen could write this equation? Then solve the equation and show your work by writing the equation on your paper and after each legal move. Okay, so let's start with that. Actually, why don't I just work it through with you? You probably don't want, you can draw it as I'm writing it up here, and I'm pretty sure the online tool, it doesn't have it started for you, so you'd have to put it on there. Although I would like for you to try and do that. That would be very helpful. But I'm going to go ahead and do this right now. So I'm thinking of a number. Okay, there's your number. If you add 2 to the number, so add 2 to it, 1, 2, and then triple it. Okay, well, this is interesting. So we're going to triple it now, which means I'm going to have 2 x's and 2 2's. No, I'm going to have 3 x's and 3 2's. So this is interesting. It told you to add 2 to a number before tripling it, which means that if you're going to write this expression, you started off with no, no, yes. You started off with x plus 2, but then you tripled it. And after you do all of that, you get 9 for an answer. So let's go ahead and put our 9 over here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so when it says write this in 2 different ways, the one way to do it would be to write it using the parentheses, right? You start with a number and you add 2 to it. Then you multiply times 3. So remember, order of operations is telling us you have to multiply before you add. Excuse me. Unless we put the addition problem inside parentheses, then you're giving the addition the highest priority. So if it's telling me to add or find the sum, then multiply, that expression to find the sum has to be put in parentheses. This is one way to write it. Now, after sending in the dive bombers, this is what it ends up looking like. 3 groups of x plus 2 ends up giving you 3 x's plus 3 2's, which is 6, and that would equal 9. So I believe that when they say, what are 2 ways that you could write this equation, those are the 2 ways. One with the parentheses and one after using distributive property. So now solve the equation. Okay, so this would have been the first step, would be to write down the equation exactly how it's presented within the problem, then start the process of simplifying, and that involves distributive property for this situation. Now we look for 0 pairs, and there are no 0 pairs on either side. This is 2 terms, this is 1 term, nothing more to simplify. So now we can begin removing balanced sets. So I'm going to take away 6 from the left side and 6 from the right side. When I remove balanced sets, I do not change the fact that both sides are equal to each other. Everything stays balanced. So by taking away 6 from each side, I end up with 3 x's on the left side and 3 on the right side. Now, let's sort these guys. How many 1s can go with each one of those x's evenly? And it looks like every one of those x's gets 1, 1. So when you show that you divided each side by 3, you end up with x is equal to 1. And that ends up being the solution. Now, we should check that. Let's make sure that's the number that Chen's sister was thinking of. She's thinking of a number. If you add 2 to that number, 1 plus 2 is equal to 3. Then you triple that number, multiply that times 3, that gives you 9. You get 9. Yes, that is precisely what we got. So we feel good about this answer. We're going to declare our answer was Chen's sister was thinking of the number 1. So when Chen told his sister the mystery number in the riddle, she said he was wrong. Chen was sure that he had figured out the correct number. Find a way to justify that you have the correct solution. All right, so let's just use the original equation. If we think that the solution is 1, then we are going to take and substitute it in here. Now we use the order of operations. 1 plus 2 is 3, and 3 times 3 is 9. That is absolutely correct. Chen's sister, she knew the number was 1. She was just lying to Chen. I'm certain of it. It's not very nice. All right, now solve the equation. 4 times x plus 3 is equal to 8. Let's take a look at how this would look on the equation map. 4 groupings of x plus 3. So let's start with an x plus 3. And now we need 4 of those, right? So we should have 4 x's and 4 3's, which gives us a total of 12. So we're going to rewrite this as 4 x's plus 12 is supposed to be equal to 8. What do I want to do here? I'm going to take this guy and I'm going to go 1, 2, 3, 4. And that should make 8. That will work. All right. Go ahead and solve this equation. Unpause when you've got the solution. All right, so if we're just looking at the equation mat here, first thing I would think of is, well, let's remove balanced sets, right? And so you could take away 8 from each side. That would be the legal move. Let me put these guys up there. But now you've got the situation where we took away 8 from each side, and you got 4 x's plus 4 on the left, and you've got nothing on the right. And our goal has always been to get our x's by themselves on their left or on one side and a constant on the other. So this was not the most efficient move we could have done. Now we should probably add 4 negative x's to each side. 1, 2, 3, 4. And then we'll do the same thing on the other side. 1, 2, 3, 4. And these form 0 pairs, which now leaves us with 4x is equal to negative 4. So that means that each one of those x's has to be equal to negative 1. Now, what most students would probably do is this. They would say 4x plus 12 is equal to 8. I want to get the 4x's by themselves, so I'm going to take away 12 from that side, which means I will do a subtraction problem. 8 minus 12 is negative 4. So eventually, it gets a lot more efficient to just solve it algebraically than working through the visual of the equation math, right? Because what we would have had to do, and I purposely did it this way, I really didn't want to add 12 negatives to the left side and 12 negatives to the right side and then remove all those 0 pairs. So how you choose to manipulate it with the math might be different than the easiest way to solve the problem here. That's supposed to be an equal sign, by the way. X is equal to negative 1. Okay? Now, I want to test this to make sure that that is correct. If x is equal to -1, then for the check, I will say that 4 times -1 plus 3 is supposed to give me 8 for an answer. And -1 plus 3 is 2. So 4 times 2 is equal to 8. Yeah, that's correct. So I feel good about my answer. I draw a box around my solution, around my answer, and we are good. All right, this is a stoplight problem, so let's see what the issue is. It says when you solve an equation that has one solution, you get a value for the variable. But how do you know that you have done the steps correctly and that your answer works? I've been showing you this. This is called the check, right? Look at your answer for problem 61. How could you have verified that the solution is correct? Well, we did it. We did it right here with the check. Okay, so when Kelly and Madison compared their solutions for this equation, x minus 7 is equal to -2x plus 1, Kelly got an answer of 2. And Madison, she got an answer of -1. So we need to figure out which one is correct. So what do? We substitute our solution here and here for Kelly's solution, or for Kelly's check, and for Madison's check, we plug in, did I not do that correctly? I think I might have made a mistake. That's supposed to be a -1. That is right there. Okay. So go ahead and run through and see if 2 makes both sides equal. If it does, Kelly is correct. Or check and see if -1 makes both sides equal. If it does, then Madison is correct. Go ahead and pause it and work through the process, and unpause when you're ready for the reveal. All right, let's see what happens here. With Kelly, this ends up being 4 minus 7, which is equal to -3. And on the right side, that's -4 plus 1, which is also equal to -3. So Kelly is correct. Now let's see what happened with Madison. 2 times -1 is equal to -2 minus 7 is equal to -9. And on the right side, -2 times -1 is +2, right? Negative times negative is positive, and 2 plus 1 is 3. That is not correct. So we verified that Madison is the one who was correct. We checked her work, and we verified that her solution is the right one. All right, so let's go. Kelly solved the equation 4 times x plus 3 is equal to 8 from problem 61. Her work is shown at the right. 4 times x plus 3 is equal to 8, so x plus 3 is equal to 2. Does x plus 3 have to be equal to 2? Why would that be? Well, let's think about this for a second. This quantity right in there is what's being multiplied times 4. And 4 times 2 is 8. So doesn't that make sense that that quantity, x plus 3, would have to be equal to 2 to make 4 times this quantity equal to 8? Yeah, I agree with that 100%. So Kelly thought about a new process where instead of using distributive property, maybe if you divide both sides of the equation times this multiplier that's being multiplied times the quantity inside the parentheses, maybe that's an actual legal move that would work. So let's see what we have. Why does that work? Yeah, because 4 times 2 is equal to 8, absolutely. What did Kelly do to remove 3 units from the left side of this equation? It looks like she added the -3 there, right? And whatever you do to one side, you do the same thing to the other. So adding balanced sets is absolutely a legal move for equations. So you either take away 3 from each side or add a -3 to each side. And in this case, it actually makes sense to add the -3 because you can take away 3 from the left, but you can't take away 3 from the right. You've only got 2 there. But we know that 2 minus 3 is equal to -1, so we'll just work with it, right? So if Kelly were solving the problem 3 times x minus 5 equals 9, what might her first step be? Well, I generally recommend that you send in the dive bombers and use distributive property, but you don't really have to. So why don't you go ahead and maybe this is for Kelly, right? She did this step up here first. So see if you can figure out, and pause and see if you can figure out the first step and the second step, doing it Kelly's way instead of sending in the dive bombers. All right, so I think Kelly would divide both sides by 3, so it would look like this. So we know 3 times something is equal to 9. That's 3 times 3, right? So that means that the x minus 5 must be equal to 3. So then the second step would be to add 5 to each side, and that would give you the answer of 8. So does that absolutely work? Let's check it. If 3 times x minus 5 is equal to 9, and we think that x is equal to 8, then 8 minus 5, does that give you 3? It does. And 3 times 3 is equal to 9, so we know that we've got our answer correct. So we can draw a box around our solution and feel confident that the solution to this problem is 8. All right, here's your opportunity. You're going to take a little bit of time here. If you want to use the student tools online, feel free to do that. You can build these, or if you want to just try and do it algebraically without actually using the algebra tiles, I'm cool with that as well. But the tiles can be helpful. Drawing these and trying to figure it out from the drawings can be way more complicated than helpful. So either use the online tools to build these equations with the x's and the ones and so on and so forth, or try your best to solve them algebraically. After you've got a solution for each one, check to make sure that your answer is correct. Okay? Pause while you do that, and unpause when you're ready to see if you got your answers correct. This is really, really important, okay? This is like a huge foundational piece for algebra. Being able to solve these equations is just as basic to algebra as knowing your sums, your differences, and your times tables are for just general mathematics, those skills that we learned in first, second, third, and fourth grade. Okay, so take your time on this, show your work, record all the steps along the way to ensure that you're not making any mistakes. Okay, I'm going to start with the reveals. Then I'm going to go through and do each one of the problems very, very quickly, but you'll be able to see with the algebra tiles and with me recording my work how we get each one of these answers, and then I'll do a quick check as well. Okay, so starting off with the answers for A, your answer is 2.5 or 2.5. For B, your answer is -7. For C, the answer is x equals -5. For D, your answer is 2. For E, your answer is 0. And for F, your answer is 2. Okay, so if you did not get those answers, go ahead and pause and cross out your answer and write in these answers, and then see if you can figure out where you made your mistake. Okay? When you unpause, you'll be able to see me working through the problems. And if you want to fast forward the ones you got correct and just look at the ones where you got wrong, that would be a great way to save time. So go ahead and pause and make your corrections if you need to. I'm going to work through problem number 1. So first off, after creating this on my equation map, I notice there are 4 x's plus 4 plus 1 plus -x. And on the right side, you have your x plus 10. So I'm going to start with removing zeros and combining like terms. So this becomes 3x plus 5, right? 4 and 1 make 5. 4x and -x make 3x is equal to x plus 10. I'm now going to take away 1x from each side and take away 5 from each side, and that's going to result in me having 2 x's on the left and 5 on the right. So take away an x from each side, take away 5 1s from each side. I think that's 5. No, that's 3, 4, 5. Now this is where it gets a little bit tricky using the tiles, because when you try and evenly distribute all of these, you got this guy that you got to cut in half, but we can't cut it in half. So that's where we know that x is equal to 2 plus half of one of these guys, 2.5 or 2.5. Okay, so let's check that and see if that works. 2.5 plus 1 is equal to 3.5. So 4 times 3.5 plus 1 minus a 2.5 should be equal to 10 plus 2.5, which is 12.5. So let's check this out. Let's 4, use the calculator. 4 times 3.5 is equal to 14. 14 plus 1 is equal to 15, and 15 minus a 2.5 gives you the 12.5. So we know the answer is correct. We're going to draw a box around that. For problem B, we got two x's, a negative x, and a 1. Here you got an x, a negative x, and 1, 2, 3, 4, 5, 6, 7, 8 negative 1s. So when we combine our zero pairs here, they cancel out, and these guys cancel out, leaving you with an x and a negative 1 on this side, and on this side you got 1, 2, 3, 4, 5, 6, 7, 8, negative 8 still. Now if I add 1x to each side, actually, you know what? I can take away a negative from each side, can't I? That actually works in this case. So by taking away a negative, that is essentially the same as adding a positive, right? KFC, so this becomes x is equal to negative 7. Let's check that. Negative 1 plus 2 times negative 7 is negative 14. Minus a negative 7 would be the same as plus 7, is going to be equal to negative 7 minus 8, and then minus a negative 7 is plus 7. So these guys cancel each other out, leaving you with negative 8. On this side, you're going to get negative 15 plus 7, and negative 15 plus 7 is also equal to negative 8. So that is correct. Draw a box around our answer. For problem C, we take 2 times x minus 4, which becomes 2x minus 8 plus the 5. And on the right side, you got your 4x plus 7. So I'm going to remove my zeros. 1, 2, 3, 4, 5. Remove all of those zero pairs. Then remove, well, actually, let me rewrite this now. So that becomes 2x minus 3 is equal to 4x plus 7. And now I'm going to take away 2 x's from each side. 1, 2 from the left, 1, 2 from the right. And that gives me negative 3 is now equal to 2x plus 7. And now if I take away these 7, I'm going to add negative 7 to that. So let's just take away that, and then let's add negative 7 to this. I'm not going to show that adding of negative 7, but you'll see that this leaves you with your 2 x's, and that gives you negative 10. So when you divide each side by 2, x has to be equal to negative 5. So let's check and see if that works. Negative 5 and negative 4 make negative 9. 5 plus 2 times negative 9 is negative 18, which gives you negative 13 for an answer. On the right side, you got 4 times negative 5, which is negative 20, and negative 20 plus 7 is also equal to negative 13. So yes, when x was equal to negative 5, both sides were equal to each other. Here you got 9 minus 3x and 1 plus x. So no zero pairs. So I think what I'm going to do is I'm going to collect my x's on the right-hand side. I can take away 1 from each side. That's pretty easy to do. Take away 1 from each side, and that leaves you with 8 on the left side. But I'm going to add 3 x's to this side. 1, 2, 3, which means I have to add 3 x's to this side. 1, 2, 3. Okay, so those make zero pairs, so those go away. So now I added 3 x's to each side, which gave me that canceled 4 x's on the right, and that canceled gave me 8 on the left. So when you divide these, divide them by 4, you get x on the right side, 2 on the left. Okay, can you see how every one of those 2 matches up with one of these? So let's check it. 9 minus 3 times 2 becomes 9 minus 6, should be equal to 1 plus 2. 9 minus 6 is 3. 1 plus 2 is 3. Yes, that works. 2 is our solution. E, you got 3 x's plus a 3 plus a negative x, or minus an x, plus 2. When we, and on the right side, you got an x plus 5. So it looks like there's only one zero pair here. Let's remove balanced sets. Wait, I'm going too quickly. Let's show the work. First, 3x and a negative x makes 2 x's, and then the 3 plus the 2 is going to give you a total of 5. And on the right side, you got x plus 5. So let's take away 1x from each side. Take away an x, take away an x, and let's take away 5 from each side. There's taking away 5. There's taking away 5. So we're left with x all by itself on one side, and nothing is over there, right? So when everything gets canceled out, that leaves you with 0. But here, not everything was canceled out. You got an x. So could 0 be the solution? 0 plus 3 is 3, and that's minus 0 plus 2 is going to be equal to 0 plus 5. Yeah, 5 is equal to 5. That is correct. 0 was our solution. And now for the last problem. 3 times 2x plus 1 becomes 6x's. And then 3 times 1 is 3. And then minus 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 4 on the left, and then all of this on the right. Let's combine like terms by creating our 0 pairs here. Hey, come on. Must grab them. Yes. 3 and 3, good. Okay. So that leaves us with the 4 on the left, the 6x is on the right, but now we just have 8. 1, 2, 3, 4, 5, 6, 7, 8. So now let's go ahead. I'm going to add 8 to this side and add 8 to this side. But I don't really want to show it because that's a pain. So we know that's going to cancel all these guys out, right, when you add 8 to it. So they're going to go away as 0 pairs. And then this is going to become 12 is equal to 6x. Okay, fine, I'll show it. Yikes. 1, 2, 3, 4, and then let's triple that. So that's 8, and that's 12. Okay, so now we've added, wait, no, I only added 8 to each side, not 12 to each side. Wait, I'm messing things up. My mistake, get out of there. I was supposed to only add 8. So that leaves me with a total of 12. So how many of these can we sort for each one of those x's? Looks like every one of those x's is going to have 2 1s along with it, and that is correct. So when you take 12 divided by 6, you get 2. So x is equal to 2. Let's check it here. 2 times 2 is 4. 4 plus 1 is 5. Is 3 times 5 15? And 15 minus 11 is supposed to equal to the 4, right? And it does. So we've got the correct answer. And I think we are done for the lesson. Hooray! All right. Yeah, there's a little bit of time to show all that work for sure. But this is what you got to do in order to be able to solve equations. Now, eventually, we're going to get to a point, as you saw with the 5D process in chapter 5, we don't just solve random equations. All of the equations that we solve have something to do with the situation where we find the relationships between our variables, and we've set up an equation to help us find the missing piece, find the answer to the question. And so a lot of these get really, really complicated, and that's good exercise for you, but eventually you're going to be using algebra to solve word problems. And it's going to make your job much easier than it has ever been in the past when you didn't know how to do algebra. So keep practicing this. Every time you see algebraic equations like this, work through the process, record your work, and check your answers to make sure you're correct. And you are going to be an expert at this in no time. All right? Take care. Bye.
Hey, feeling good, like I should. When in dark, walk around the neighborhood. Feeling blessed,